Have you ever stopped to think about how we teach the biggest ideas in science? I mean, not just random facts, but these huge, mind-bending concepts like energy, our planet, and the entire cosmos. Well, today we're diving into the game plan, based on a natural science study guide, to see exactly how educators turn these massive topics into real moments of discovery. And really, it all comes down to this one massive question. How do you take the sheer scale and complexity of the universe and make it not just understandable, but genuinely exciting for a young mind? That's the puzzle we're digging into today, by looking at the really clever way it's done. So, here's our roadmap for this explainer. We're going to start with the four big ideas that are basically the foundation of all science. Then, we'll zoom in on two of them, energy and our planet. After that, we'll get into the engine room of science, the experiment, before we tie it all together to see what the real and maybe surprising goal of science education is. Okay, so if you want to teach science well, you can't just throw a bunch of facts at someone. You need a system, a framework to hang all that knowledge on. And in natural science, everything is built around four key pillars. And this right here, this is basically the blueprint for the entire subject. You've got the world of living things and the world of non-living materials. And then you have the two we're really focusing on today, energy and change, which is all about the invisible forces that power our world, and planet Earth and beyond, which connects the very ground we walk on to the stars way up in the night sky. So what does energy and change actually mean in a classroom? Let me tell you, it's so much more than just learning about electricity and light bulbs. You see, it's all about this fundamental flow. It's the energy from the sun that helps a plant grow, right? And it's the chemical energy in the food we eat that fuels our bodies. But it's also about understanding the consequences of how we, as humans, power our lives. It's this amazing link between biology, physics, and society. Now, to make a big, abstract idea like this feel real, you've got to use examples we can actually experience. So instead of starting with some complex formula, a lesson might be all about sound. By investigating what makes the sounds we hear every single day, a student isn't just memorizing a fact, they are literally experiencing a principle of physics. They're feeling energy in motion. All right, so from the tiny vibration of a single sound wave, let's zoom way out to the grand scale of our entire planet and its place in the universe. This area is all about connection and scale. It's about seeing how a mountain range over here can influence weather patterns hundreds of miles away over there. It's about realizing our planet is just this one small, incredibly precious part of a vast solar system. It's all about understanding the interconnected systems that make our world work. And this illustrates something so cool. Earth isn't just a big rock. It's a living, dynamic system. You have the biosphere, which is all life, the atmosphere, the air we breathe, the lithosphere, the solid ground, the hydrosphere, all the water. And guess what powers it all? An energy system, mostly from the sun. When you get how these five parts interact, you start to understand everything from climate change to earthquakes. Okay, so we've got these huge topics, energy, Earth, the universe, but how do you actually teach them? Well, here's the secret sauce. It's not about memorizing facts. It's about learning how to investigate and discover things for yourself. This, right here, is the absolute heart of modern science education. The goal isn't to create walking encyclopedias. No, it's to cultivate a mindset of inquiry. It's about empowering students to become active investigators who know how to ask a really good question. And, this is the most important part, how to design a way to find the answer. And the key to any good experiment is understanding variables. This table breaks it down perfectly. The independent variable, that's the one thing you change on purpose. The dependent variable, that's what you measure. It's the effect you're looking for. And the controlled variables, that's everything else you have to keep exactly the same to make sure it's a fair test. Let's make this real with an example. So, the goal is to determine if the size of the parachute affects the rate at which it falls. What's the one thing we are intentionally changing? The size of the parachute. That's our independent variable. And what are we measuring? How fast it falls. That's our dependent variable. Simple, right? To make it fair, we'd have to control things like the weight we attach and the height we drop it from. All right, now let's see how this works with some actual classroom data from a classic pendulum experiment. So in this experiment, we're trying to see if the string's length changes how many times a pendulum swings. The string length, which we're changing from 60 to 40 to 20 centimeters, that's our independent variable. The number of swings we count, That's what we measure, so that's our dependent variable. And by keeping everything else the same, we can actually see a clear relationship between cause and effect. Okay, so you see how this all connects. The big ideas about our planet, the flow of energy, the nuts and bolts of experiments, it's all building towards one single powerful goal. And this is the main takeaway. The facts are important, but they're not the point. Knowing the definition of lithosphere is useful, sure, but knowing how to design an experiment to test an idea, that is a superpower. The real goal is to spark curiosity and give learners the tools of science itself, tools they can use for the rest of their lives. So in that spirit, this isn't really an ending. It's an invitation. Because once you start seeing the world as a series of fascinating puzzles and you realize you have the tools to investigate them, well, it leaves you with one powerful thought. What are you curious about? What question will you investigate next?